So when you have a system of linear equations where both equations are written in standard form like this, not slope-intercept form, sometimes it's a lot easier to use elimination to find the solution, again, to find where the two lines intersect rather than substitution. So how do we do elimination? Well, we want to look at the coefficients of the variables, and then we're going to choose either to eliminate x or y. So if I'm looking at this system of equations here, I want to find the variable where the two coefficients are exactly opposite of each other. So here, right, I have a 1 in front of the x and a 3 in front of that x. Those are not opposite of each other. So let's take a look at the coefficients for y. Here I have a positive 1 for that y and a negative 1 for that y, and that's what we're looking for. They're the same number, just opposite signs. So all we're going to do is we're going to add these two equations, just like you did back in elementary school, adding 2 3-digit numbers. So it'll look something like this. Let's do x plus y equals 2, and then 3x minus y equals 2. And we're literally going to add it. So we're going to add the x terms together, the y terms together, and then the constants together. So x plus 3x, that's going to be 4x. A positive y and a negative y is going to give us 0y. And then 2 plus 2 is 4. So 0y, right, we can just cancel that out. We know that's going to be 0. And as you can see, we have eliminated the y variable. That's why this is called elimination. So we can now just look at 4x is equal to 4 and solve for x. So if I divide both sides by 4, those 4's will cancel, and I'll get x is equal to 1. All right, so now you do the same thing that you did in substitution. Once you get one of your variables, just plug it into either one of the equations above and solve for y this time. So let's use that top one. We got x plus y equals 2. Instead of x, I'm going to replace it with 1. So I'll have 1 plus y is equal to 2. I want to get y by itself, so I'll subtract 1 from both sides. Those will cancel, and I'm left with y is equal to 1. 2 minus 1 is 1. So our solution for this system of equations is going to be 1, 1. Plug your equations into Desmos if you're not sure or just want to check your answers, but there we go, 1, 1. Okay, for this one, we don't, off the bat, have two coefficients that are opposite, the same, just opposite signs of each other, but it's pretty close. That y is really, we got negative 2 as the coefficient for both of the y terms. So we're going to do this. We're going to multiply one of the equations by negative 1 to flip that sign. So it doesn't matter which one you do, but we can do the bottom one. So if I multiply every term in that equation by negative 1, what I will get is negative x plus 2y equals negative 6, right? And then if I just bring this guy down, 3x minus 2y equals 2. Now I can do that addition trick that we did in the last problem, right? So 3x and a minus x, if I add those together, I'm going to get 2x. Negative 2y and plus 2y, that's going to be 0. So those will cancel out. Equals 2 plus minus 6 is going to be negative 4. So I have 2x is equal to negative 4. Divide both sides by 2. And we will get x is equal to negative 2. Again, plug that into either one of the original equations to get y. Let's do the bottom one. So we'll take x minus 2y is equal to 6. Instead of x, we're going to replace that with negative 2 minus 2y is equal to 6. I'll add 2 to both sides. So that's going to cancel out. We'll get negative 2y is equal to 8. Divide both sides by negative 2. Those negative 2's cancel. I'll get y is equal to 8 divided by negative 2 is negative 4. So the solution to this system of linear equations is going to be negative 2 comma negative 4. And there it is in the graph, negative 2, negative 4. Okay, for this one, we're going to have to tweak we're going to have to tweak both of these equations to get one of the variables to be canceled out or eliminated. And since I think we've eliminated y for the previous problem, so let's eliminate x. All right, so I'm going to look at the coefficients here. The good news is that they are opposite signs, so one's negative, one's positive. We need to figure out what the least common multiple of these two numbers is, and that's going to be 14, right? 2 can go into 14, and 7 can also go into 14. So I'm going to multiply this top equation by 2, and then I'm going to multiply this bottom equation by 7. All the terms, right? I'm going to multiply 2 into every single term here, and then 7 into every single term here. So the new equations that I'm going to get are negative 14x plus 4y is equal to 4. That's what this red one is going to become now. And then the blue one is going to become positive 14x minus 21y is equal to negative 21. So now we can do the addition, and you can see that the x term, the x variable, that's going to get eliminated because negative 14x plus 14x is just 0. And then we can look at the y terms here. Positive 4y minus 21y, that's going to be negative 17y is equal to 4 plus negative 21 is going to be negative 17 as well. Divide both sides by negative 17 to get y by itself. And we get y is equal to 1. All right, so plug that back into either one of the two original equations. We'll go with the bottom one. So we have 2x minus 3. Instead of 3y minus 3y, we're going to do minus 3 times 1 equals negative 3. All right, so we'll have 2x. Negative 3 times 1 is going to be negative 3 equals negative 3. I'm going to add 3 to both sides to get x by itself. I'll get 2x is equal to negative 3 plus 3 is 0. Divide both sides by 2. X is equal to 0. So this solution is going to be 0, comma 1. And there you have it right there, 0, 1. Okay, last one. So with this one, we can decide whether we want to eliminate x or y. It doesn't really matter. You can see the coefficients here for the x's, they're both negative as they are here for the y, so we're going to have to change that. Let's eliminate y first. So if this is positive 9 and this is positive 3, the least common multiple of those two numbers is 9. So we don't have to change this at all. It's already where it needs to be. We just need to make that coefficient, we need to make that into a negative 9 so that it cancels out with that positive 9. So what I'm going to do is I'm going to multiply this entire equation by negative 3. Right? If I distribute that in to all those terms, I'll get 3x minus 9y equals negative 18. Right? And so then I'll bring this red equation back on top of it. So negative 4x plus 9y is equal to 9. We'll do our addition here. So negative 4x plus 3x is going to be negative x. Negative 1x, negative x. That cancels out. That's the whole reason we did this, so we could just put plus 0y if we wanted to. And then 9 plus negative 18 is going to be negative 9, right? So the 0y we can ignore because that's just 0. We'll get negative x is equal to negative 9. Divide both sides by the negative 1 to cancel those out. And we'll get x is equal to 9. plug that back in to either one of the two original equations. How about, we'll do the bottom one, because x only has -1 as the coefficient there. So we'll have negative x plus 3y is equal to 6. Instead of negative x, how about we make it a -9 from over here? Plus 3y is equal to 6. I'm going to add 9 to both sides. That cancels out. We'll have 3y is equal to 6 plus 9. That is 15. Divide both sides by 3 to get y by itself. And we get y is equal to 5. So this solution is going to be 9, 5.